Assalamualaikum. So today we are going to do carboxylic acids and esters. Now the primary idea is that carboxylic acids have the carbonyl group in them. So they always have C double bonded O. But they also have another O attached to that carbon, and that makes a lot of difference when it comes to the properties of these things. And that's attached to hydrogen, and of course on this side I have an R. R would mean it is any organic part, but we are not talking about that at the moment. Now they're different from esters in the sense that esters have the same C double bonded O and then another O, but this time they are not attached to hydrogen, they are attached to another R. It will be a different one, and this shows that one is an ester and one is a carboxylic acid. Now of course you can have different forms of this, you can have different branches of this, and all of that doesn't matter because the primary thing that makes them acid or ester is this COOH or COO group in them. Now carboxylic acids, let me focus on that. Carboxylic acids are very different from other carbonyl groups, and the primary reason for that, as I've told you, is this oxygen. In fact, the effect of this oxygen is so much that virtually they don't have anything in common with carbonyl groups. Like none of the reactions of carbonyl groups are present in carboxylic acid. And the reason that works is because this bond between oxygen and hydrogen is polar. And because of that polarity, it is possible that this bond will be broken, or this can make H positive ions, which is why they become acids. So that happens. But because even though this bond can be broken, this oxygen is still attached to this carbon. And because of that, the ionization or the extent of ionization is very low, which is why we call them weak acids. So sure, वो ये इस हाइड्रोजन को छोड़ सकते हैं, but वो बहुत ज़्यादा ये नहीं करते हैं, जिसकी वजह से उनकी ionization इतनी ज़्यादा नहीं है, and that makes them weak acids. Now, when it comes to boiling point or other physical properties, these things have higher boiling points than alcohols, and of course alkanols, which is alcohol, even aldehydes. And the primary reason why that happens is hydrogen bonding. They are able to form hydrogen bond with each other, and not just with each other, with water as well. So the reason that happens is, for example, if I have two acid groups in there, so I have this thing and I have this. Now there's the slight positive charge here, slight negative charge here. Similarly, this slight negative charge here because of carbon-oxygen bond being polar as well. There's lone pairs here, and remember that for hydrogen bond to occur, there must be hydrogen in a polar bond, and the other thing must have lone pair. And that's exactly what happens there. So this oxygen also has lone pair, and that oxygen also has lone pairs. And let's say I have another acid, and I'm going to draw that like this. So when that happens, and I have another R here. Now this is again delta positive, delta negative, there's lone pairs here, lone pairs here. So अब क्या होगा? You can clearly make hydrogen bond with these. And this is the hydrogen bond that you have. And this hydrogen bond shows that one hydrogen is in a polar bond, and the other atom, oxygen in this case, has lone pair in it, which is why they're able to form hydrogen bond, which means their melting and boiling points are much higher than aldehydes or alcohols of the same MR or same number of carbon atoms. Okay, so water के साथ भी ऐसे ही होगा. They can form hydrogen bond with water, and which is why that they are soluble in water to a greater extent than alcohols. So these are generally soluble in water, again because of hydrogen bond, but ये solubility आपकी सिर्फ इस part पे हो रही है. If this part becomes longer, then the longer it becomes, we call that a non-polar tail. So there is a longer non-polar tail, which means London dispersion forces इसकी वजह से आएंगी, तो उसकी वजह से उनका impact ज़्यादा होता जाएगा. The bigger this R, the bigger this chain of other non-polar parts, the lower the solubility of that acid. तो अगर आपके पास बहुत छोटा molecule है, like methanoic acid, it will be the greatest solubility comes in that. Similarly, ethanoic acid, very much soluble. But जैसे जैसे ये हाइड्रोकार्बन चेन या जो भी इसमें आपके पास अदर ग्रुप्स हैं, वो जैसे जैसे बढ़ते जाएंगे, नॉन पोलैरिटी है और नॉन पोलर है वो, तो उसकी वजह से वो इनसॉल्युबल होता जाएगा. In fact, it becomes insoluble when you get C8. at C8 which means octanoic acid, उसके बाद वो इतने बड़े मॉलिक्यूल्स हो जाते हैं और उसमें लंदन डिस्पर्शन फोर्सेस का इतना ज़्यादा इम्पैक्ट हो जाता है कि उसके बाद ये इनसॉल्युबल हो जाते हैं. Okay, so that's another important point to remember. Now when it comes to their reactions, there are two things जिनसे carboxylic acid बनता है and two things जो carboxylic acid से बनती हैं. So there are two reactions that cause our carboxylic acid that we need to know about and two things that are made from carboxylic acid जिनका हमें पता होना चाहिए. ठीक है? So let's start with how do you prepare carboxylic acid. So the first method for that is what we've seen before, oxidation of primary alcohols. Now important thing to remember, you cannot have secondary alcohols or tertiary alcohols to make this because one, secondary alcohols will make ketones which cannot be further oxidized and tertiary alcohols cannot be oxidized at all क्योंकि उनमें हाइड्रोजन लूज करने की एबिलिटी नहीं होती. सो हाइड्रोजन लूज करेंगे तो कार्बोक्सिलिक एसिड बनेगा. सो यहाँ पर क्या होता है कि हमारे पास अगर कोई भी अल्कोहल है, सो लेट्स सपोज मेरे पास ये अल्कोहल है, R है, उसमें कार्बन है, OH बॉन्ड है और कोई और हाइड्रोजन है और ये there you go. Now what will happen is that I need to remove two hydrogens, one from this OH part and one somewhere else, in fact from the adjacent carbon, तो वो यहाँ से remove होगा. So अगर मेरे पास कार्बन पर भी एक हाइड्रोजन होना चाहिए और OH में तो H है, and if I am able to remove that, then I will be able to oxidize this thing. And I need strong oxidizing agents for this. और अगर आपको directly alcohols उसको बनाना है, then you want to basically bypass the aldehyde route, which is why we use reflux. So we need heat with reflux, and I need a strong oxidizing agent. So I could use K2Cr2O7. I could also use KMnO4, but for them to work properly, I need this to be acidified. So ये सारा important है आपको याद रखने के लिए. Exam में आप ये नहीं लिख सकते कि potassium manganate 7, because acidified potassium manganate 7 is what you need. And of course then you heat and reflux. अच्छा, तो ये oxidation हो जाएगी. What will happen is these two, so everything else remains the same. These two are lost, and then further hydrolysis happens, and you're going to get OH. So usually हम इसको इस तरह से नहीं draw करते. Usually what we do is we draw it like this. Okay, and you can clearly see that carbon is in a 120-degree bond, and 3 sigma bonds there. This is sp2 hybridization. Okay, and that's the bond you're going to get in here, which is why we always try कि हम bond angles सही रख के bonds को बनाएं. इस पे marks नहीं lose होंगे, of course बेस पर हर जगह वो apply नहीं करवा रहा आपसे, but this will keep your concept fresh और आपको याद रहेगा कि इसमें bond angles 120 रखने हैं मुझे, and it will also be a planar molecule. अच्छा, so ये तो हो गया when you oxidize primary alcohol. So whatever alcohol you have, if it is primary, which means carbon is attached to just one more carbon, or just with hydrogen, जैसे methanol है, then this will work, and you have to use reflux if you want to go directly. You can obviously use distillation to make aldehyde first, और उस aldehyde को भी हम oxidize कर सकते हैं. So that's the thing, that you can also oxidize aldehydes. Now the thing with aldehydes is that they are waiting for oxidation. So वहाँ पर कोई भी आपके पास oxidizing agent होगा तो वो काम कर सकता है. So we have 4 options now: K2Cr2O7, Fehling reagent, Tollens solution, and KMnO4 obviously with acid. तो हम कोई भी aldehyde लेते हैं. aldehyde में क्या होता है कि आपके पास कार्बन है, उसमें ऐसे डबल बॉन्ड है और यहाँ पे हाइड्रोजन है, तो ये आपके पास स्ट्रक्चर होता है उसका, and you just need an oxidizing agent. Once you have the oxidizing agent, you can oxidize this and you can get RCOOH. Okay, so that is what you will get. और ये oxidation आपकी कोई भी oxidizing agent कर सकता है, and we have 4 oxidizing agents. I'll just list them. So you have acidified K2Cr2O7, which is potassium dichromate or potassium dichromate 6. Similarly, you can have acidified potassium manganate 7, KMnO4. You can also have Tollens reagent, and you can have Fehling solution. So इनमें भी आपको याद रखना है कि क्या आपके पास observations हैं. So एक में आपको blue to red हो जाता है because copper 2 changes to copper 1, and that is the thing being reduced itself but oxidizing the other part. And the other is you will get a silver mirror because silver ion से silver metal बन जाएगा आपके पास. Alright, so that is the other part where you get कार्बोक्सिलिक एसिड. सो पहला रिएक्शन मैं आपको बताया था कि दो रिएक्शन है जिससे ये बनते हैं. तो पहला रिएक्शन है ऑक्सीडेशन, और ऑक्सीडेशन आप एल्कोहल्स की कर सकते हो और एल्डिहाइड्स की कर सकते हो. नाउ लेट्स लुक एट द सेकंड रिएक्शन. Second reaction that causes or forms carboxylic acid. So second reaction that forms that is hydrolysis. So पहला reaction क्या था? Oxidation. और वो आप aldehydes की कर सकते हो, वो आप alcohols की कर सकते हो, primary alcohols only, and that will form carboxylic acid. Now you can also do hydrolysis. और hydrolysis किसका होता है? Cyanide, जिसको हम nitrile भी बोलते हैं. So you take nitrile और उसका hydrolysis आप करेंगे, and again to do hydrolysis correctly you need some protons, some acidified solution. So इस वजह से, या अगर acidified नहीं है, you basically need water in ionized form. So आप alkali भी डाल सकते हो, acid भी डाल सकते हो, as long as water is acidified और reaction हो रहा है. So what exactly is nitrile? Nitrile में हमारे पास कार्बन की ट्रिपल बॉन्ड होती है नाइट्रोजन के साथ. And we have used this reaction HCN, KCN या HCN and NaCN का ये रिएक्शन होता है. इससे हम बेसिकली कार्बन चेन में एक कार्बन का इजाफा करते हैं. We use it to increase the length of the carbon chain. So let's suppose मेरे पास ये कहीं से उठ के आ गया. I have some nitrile in there. This nitrile I can hydrolyze, which means I need to give it water. But this will not work unless I give it, let's say, HCl, or I could also give it some sodium hydroxide. Both of them aqueous and both of them dilute. Concentrated नहीं देना. Okay, concentrated में हमारे पास और different reactions हो सकते हैं. Okay, so what will happen now is that first of all this bond will break. So the carbon nitrogen bond breaks. This carbon is hydrolyzed. This nitrogen is hydrolyzed. So what you're going to get is two products. आपको यहाँ पर carboxylic acid मिलेगा, और इस नाइट्रोजन के साथ आपको अमोनिया मिलेगा. So carbon will hydrolyze to carboxylic acid. Nitrogen will become ammonia. But it depends कि आपने किस मीडियम में ये रिएक्शन किया. अगर आप एसिडिक मीडियम में ये रिएक्शन करते हो तो उसका मतलब है you have plenty of H positive available. So in acidic medium, what will happen is that once these two are formed, इनमें से एक चीज उन available H positive से react कर जाएगी. So obviously the thing that it reacts with H positive is a base. तो आपके पास होगा क्या? You will get RCN obviously. This will hydrolyze. I think I need to balance this. 2H2O. And let's suppose I have HCl added to it. Dilute है, aqueous है. What this means is that I have plenty of H positive available. That's the important part, and that's what you have to know. That acidic medium means that I have lots of H positive available. तो अगर कोई भी चीज उसको गेन करना चाहती है तो वो कर सकती है. तो अमोनिया के पास it has lone pair. So what will happen? Carboxylic acid तो वैसे ही पड़ा रहेगा, because वो H positive कैसे lose करे when you have plenty of H positive available already. तो वो वैसे रहेगा. But this ammonia, because of its lone pair, because of its basic properties, it will accept H positive and make ammonium. And why is that? Because you have plenty of H positive available. Now if I do this same reaction in basic medium, let's suppose instead of HCl मैंने इस reaction में ये RCN तो है, मेरे पास नाइट्राइल है, वाटर ऐड कर दिया है, हाइड्रोलाइज कर दिया है, but I have sodium hydroxide aqueous solution. And what this does is it is going to produce RCOH. Obviously it's also going to produce NH3. Now because there's lots of molecules willing to accept H positive, ये basic medium है, there's things going around looking for H positive, तो इस carboxylic acid को मौका मिल जाएगा और ये अपना H positive lose कर देगा. क्यों? Carboxylic acid is an acid, it has to lose H positive. If there is something available to react, it will react, and that is how you get this ion, whatever this ion is. Okay, so this is an some ethanoate, propanoate, some butanoate, or just methanoate ion, and that ion is formed because there is plenty of material to react with this. Now notice that nothing happened to ammonia in this case because a base in a basic medium stays the same, just like an acid in an acidic medium stays the same. ये चीजें आपके लिए हो सकता है, आपको लग रहा हो कि ये क्या हो गया, ये एक नई बात है, But ये नई बात नहीं है. It's just that we are looking at a base and an acid, both of them in the same solution. But हो क्या रहा है कि because of the nature of that solution कि वो acidic है, so just base react कर रही है, acid react नहीं कर रहा. And क्योंकि just base है तो सिर्फ acid react कर रहा है, base नहीं कर रही है react. We will see this and we will come back to this kind of reaction, especially when we talk about amino acids, because amino acids किसी भी acidic या basic solution में हो सकते हैं. तो उनमें amine group होता है which is basic, and they also have acidic group. So what they do is that amino acids have properties of both base and acid on different ends of the molecule. So what they do is that if they are put into the basic medium, तो सिर्फ acid part react करता है, and if they are put in the acidic medium, सिर्फ basic part react करता है. And that is similar to what we are seeing over here, although that part comes really later on. In fact, ये जो property है ना कि आप acid के अंदर सिर्फ acid react नहीं करेगा, base react करेगी, और basic के अंदर acid react करेगा, base नहीं करेगी. इस चीज को हम use करते हैं for a technique called electrophoresis. And that electrophoresis is a very useful technique to figure out कि अच्छा हमारे पास कौन सा amino acid है, कौन सा molecule है, mixture किस तरह से. Just like हम reactions करते थे chromatography को करने के लिए, चीज़ों को चेक करते थे, वैसे ही हम ये भी electrophoresis भी करते हैं based on this idea कि acid और base mixture में होंगे, तो depending on what kind of solution you have, only one of them will react. अच्छा, so now we know that you can make carboxylic acids from two things. One is oxidation of aldehydes or alcohols, and one is hydrolysis of nitrile. अब है तो ये acid, तो it will react like an acid. तो acid वाले सारे reactions ये करेगा. अब acid वाले reactions हमने 4 पढ़े हुए हैं O levels में. We will just stick to those. हमारे पास कोई नए reactions नहीं है. जैसे कि हमें पता है कि ये weak acid है. Weak acid होने का मतलब क्या है? Acid होता क्या है? I'll take the example of ethanoic acid. When you put it in water, it loses H positive. It's a weak acid, so it's going to lose that H positive. This H positive is lost. This is given to water. Water is acting as a base. Why? Because water has lone pair on this oxygen. So एक lone pair hydrogen ion के साथ dative bond बना लेगा, and you will get H3O positive. And this clearly shows that ethanoic acid is working as acid, even though the extent of neutralization is really slow or really low. अच्छा, अब it will not react with very unreactive metal like copper वगैरह के साथ तो react नहीं करेगा. But if I react this, again I'm taking the example of ethanoic acid. If I react it with, let's say, sodium, it will definitely react. It will form displacement reaction. Why? Because this H and this sodium can displace each other. So I will see sodium ethanoate being made. अब मुझे कैसे पता चलेगा कि मैंने एक सोडियम कहाँ लिखना है? जहाँ H रिमूव किया वहाँ पे लिख देना. And that's how you make this an ionic compound, and I'm going to get hydrogen gas. Obviously I'll need to balance this out, and there you go. So ज़्यादा reactive elements के साथ ये react करता है. You can just balance it out by putting half hydrogen. That's also acceptable. एक और reaction हमने पढ़ा था that acids react with bases to produce salt and water. So for example with alkali like sodium hydroxide, this will definitely react. This will produce water, neutralization reaction. But I will also get sodium ethanoate again because the H is lost again from here. So this is H positive, so the rest of it will be whatever it is negative, and I will get sodium ethanoate formed. हमने एक और reaction पढ़ा था कि carbonates के साथ acids give carbon dioxide, and this is no exception. This will do the same. So with carbonate like sodium carbonate, this will form carbonic acid. That carbonic acid will break down, giving us carbon dioxide, water, and of course sodium ethanoate. So again, that's just an example, but it goes on to show कि reaction किस तरह से हो रहा है. So there you go. We had two reactions that made carboxylic acids: oxidation, hydrolysis. We know that this is just a summary of acid reactions. We have seen this before in O levels. We have seen this in A levels as well, in AS. And now we're moving on to the two reactions that these can do. So the first reaction that carboxylic acids do, that is esterification. Esterification is the ability to form salt or ester bond और वो किस तरह से होती है? थ्रू कंडेंसेशन. सो दिस इज ऑल्सो एन एक्सटेंशन ऑफ कंडेंसेशन. कंडेंसेशन हमने पॉलीमर्स में देखी थी. कंडेंसेशन में ये होता है दैट यू रिमूव H and OH और बेसिकली अ स्मॉल मॉलिक्यूल. वो H और Cl हो सकता है, वो H और OH हो सकता है, वो H और NH2 हो सकता है. Anything that forms a small molecule like ammonia, water, HCl, and you join the remaining parts. So here what I'm going to do is I'm going to remove H and OH. By the way, through experimental techniques, people have figured out that in this case, when esters are made, H comes from alcohol and OH comes from acid. Now that's very interesting, but we don't have to get into the detail of कि ऐसा क्यों होता है या क्या होता है. Basically, H and OH react together, they make water. So let's suppose मेरे पास कोई भी alcohol है, which is this, और कोई भी carboxylic acid है, which is this. I just put a comma to show that this is a different one. So what's going to happen is that one is going to lose H and one is going to lose OH, and that's how I'm going to get water. Now, if I remove H from here and OH from here, whatever I'm left with, I'm going to copy that. So this part comes here, and this part comes here. And of course, I'm going to flip them. Okay, so I'm going to flip this thing, and I'm going to join it with this one. And this part right in the middle, this COO, is what makes it an ester. Okay, so I start with some acid. I start with some alcohol, I remove H and OH as you've seen, and I join the remaining parts, and I've gotten esters. So I would suggest कि आप ester का 2-3 examples करो. Let's suppose मेरे पास ethanoic acid है. In fact, let's make it slightly different. I have eth-dioic acid, and I reacted with ethanol. Now what will happen? I'm going to remove H and OH. So I will remove H and OH. But I can only remove one H. So मुझे एक और यही लाना पड़ेगा जहाँ से मैं एक और H remove करूँगा. Acid में से मैं दोनों साइड से remove कर रहा हूँ. Alcohol में एक साइड से हो सकता है. That's why I'm going to get another alcohol just like this one. So now what will happen? The remaining part, whatever is left, ये जो बाकी बचा है और ये जो बाकी बचा है, I'm going to join these together. So I'm going to get this part in the middle. It was empty on the left side, and on the left side I'm going to join it with this part, ethoxide, or on the right side I'm going to do the same. So O and C and C, and there you go. Okay, so we have found an ester with 2 ester bonds. And that's fine, कोई मसला नहीं है. We could do the same thing with 2 alcohols. Like एक alcohol है जिसमें diol है. We could do the same thing. Let's say I had CH3COOH, and I reacted with the diol, like eth12 diol. So क्या होगा? Simple reaction. You have to remove water, OH and H. Of course, ऊपर वाले में मुझे water लिखना चाहिए. So I'm going to get 2 water. I'm going to get 2 water here as well. The difference is I'm going to use 2 of ethanoic acid. And now what will happen? Whatever is left, I join that. So ये वाला part इस पूरे के साथ join हो जाएगा. और ऐसा ही यहाँ पर भी join हो जाएगा. And that's exactly what will happen. So I get this alcohol part in the middle. And now on the left side, I join whatever is left of the acid. So that is this. And same on the right side. And there you go. I found this. Now, what was I doing in all of this? I was removing water. Which means I need a strong dehydrating agent to do this. And to do that, we have concentrated sulfuric acid. And we know that. हमें बचपन से पता है, O level से पता है, that we need concentrated sulfuric acid, which is a strong reducing agent in presence of heat. It will be a really fast reaction, and this will continue. Of course, you can reverse this by adding water. अगर आपने एस्टर बना लिया है और इस एस्टर को वापस आपने करना है, so you can do nucleophilic substitution, and that nucleophilic substitution basically attacks the carbon in there इस एस्टर बॉन्ड में जो कार्बन है इसको अटैक करेगा and it will break this down and you will get the ester broken down into the alcohol and the acid that it came from. Now there are a couple of facts that you need to remember about this for hydrolysis of esters. Again इन facts की ज़्यादा detail वो आपसे अभी नहीं पूछेगा, A2 में भी शायद I don't think वो पूछेगा, but I'll quickly tell you what happens and why it happens. So न्यूक्लियोफिलिक सब्स्टिट्यूशन यहाँ पे हो सकती है, ठीक है, बट अगर हम पानी ऐड करेंगे ना तो इट्स अ रियली स्लो प्रोसेस. इनफैक्ट अगर आप डाइल्यूट एसिड भी डाल दोगे और रिफ्लक्स भी कर दोगे तब भी ये बहुत स्लो प्रोसेस है and it never goes to completion. So with acid catalyst, heat and reflux, reaction doesn't go to completion and is slow. That's the first thing you need to know about. इसको तेज करना हो तो हम एल्कली डाल देते हैं, ठीक है. एल्कली का फायदा क्या है, दैट विद एल्कलाइन catalyst, of course you need to heat and reflux. It is faster and goes to completion. Equilibrium establish नहीं हो जाता, वो dynamic equilibrium, it goes to completion. So with acid it is reversible, doesn't go to completion, but with alkali it does go to completion. So हम क्या करते हैं, हम alkalis use करते हैं. अच्छा, now the reason that it doesn't go to completion is because जो भी आपके पास एसिड बनता है ना इस रिएक्शन में, अगर आपने एसिड डाला हुआ है और एसिड के होते हुए आप रिवर्स कर रहे हो, हाइड्रोलाइज कर रहे हो, तो ऑब्वियसली आपने उसे हाइड्रोलाइज किया, एस्टर इज गोइंग टू ब्रेक डाउन फॉर्म एसिड एंड alcohol. Now that acid is going to start the reaction again with alcohol. क्यों? क्योंकि वो किसी और से तो रिएक्ट कर नहीं सकता, because you put it in an acidic medium. तो किसी और के साथ तो वो रिएक्ट कर नहीं सकता, तो वो क्या करेगा, वो उसी अल्कोहल के साथ दोबारा रिएक्शन करके वापस एस्टर बना देगा. So we need to find a way कि जैसे ही अल्कोहल और एसिड बने, जैसे ही रिवर्स हो, जैसे ही एस्टर हाइड्रोलाइज हो, तो जो अल्कोहल और एसिड बनता है, we need to take care of that. And alkali is going to help us in that. क्यों? Alkali will react with the acid that is made. Alkali की मौजूदगी में हमने रिवर्स किया, हाइड्रोलाइज किया, sure. Now the moment you get the carboxylic acid back, alkali is going to react with it. It's going to form carboxylate salt, जैसे सोडियम एथेनोएट है. तो अगर सोडियम हाइड्रोक्साइड ऐड किया होगा और एथेनोइक एसिड बना है, it will quickly react and form sodium ethanoate, which means there is no more acid remaining. और जब एसिड बचेगा ही नहीं तो वो रिएक्ट कैसे करेगा, किसी के साथ भी नहीं, तो आपका रिएक्शन रिवर्स में नहीं जाएगा. So with acid, the carboxylic acid made reacts to form the ester again, but in presence of alkali, the carboxylic acid made reacts with the alkali, and that is how you're able to get the reaction completed, और वहां से वो completion की तरफ जाता है और हमारे पास reaction complete हो जाता है. Now a couple of things you need to know about esters. Number one, esters are sweet. They have sweet fruity smell. We use them for flavoring, for perfumes. They are also very good solvents. So 3 uses: flavors, odor, मतलब perfumes, and as solvents. तो हम उनको यूज करते हैं, but they do not dissolve in water that much. क्यों? वो हाइड्रोजन बॉन्ड नहीं बना सकते. कार्बोक्सिलिक ग्रुप है उसके अंदर, COO है, बट हाइड्रोजन नहीं है, और पोलर बॉन्ड में हाइड्रोजन ना होने की वजह से दे कैन नॉट फॉर्म हाइड्रोजन बॉन्ड. सो इस वजह से नंबर 1 इनका बॉइलिंग पॉइंट, मेल्टिंग पॉइंट एसिड से कम होगा, बिकॉज हाइड्रोजन बॉन्ड नहीं है, नॉन पोलर मॉलिक्यूल्स हैं, तो आपके पास वैन डर वाल फोर्सेस ही हैं, और साथ ही साथ they will not be that soluble in water. Now the last thing, I know it might seem like बहुत ज़्यादा बातें आज कर ली हैं, but the last thing that we need to know about, मैंने आपको बताया था कि 2 रिएक्शन आपको पता होने चाहिए. पहला हमने देख लिया एस्टेरिफिकेशन, दूसरा रिएक्शन जो आपको कार्बोक्सिलिक का पता होना चाहिए वो है रिडक्शन. ऑक्सीडेशन से कार्बोक्सिलिक बनाया था ना, तो रिवर्स करने के लिए रिडक्शन करनी होगी, which means I need a reducing agent. I'll move this to the next page. So I have this acid and I want to reverse this. I want to reverse this so I can get primary alcohol back. ठीक है, हो जाएगा, but I need a very strong reducing agent. Because aldehyde नहीं बनाना है मुझे direct alcohol बनाना है. So I need a strong reducing agent, which means वैसे हमने reducing agents कौन कौन से पढ़े थे? हमने पढ़ा था हाइड्रोजन इन प्रेजेंस ऑफ निकल, हमने पढ़ा था NaBH4 aqueous solution, और हमने पढ़ा था लिथियम एल्यूमिनियम हाइड्राइड इन ईथर. Now the strongest one is lithium aluminum hydride. So this works on esters, on carboxylic acids, but these two do not work. So it's very important कि इसको use जब आप करें तो you know that only lithium aluminum hydride can be used at room temperature to reverse this. But it has to be in a very dry environment. Aqueous solution नहीं ले सकते आप. Why? Because lithium aluminum hydride is explosive with water. So you have to make sure that you do not get water anywhere near it. In fact, ether should be dry. Okay? So you use a reducing agent, a strong reducing agent, and then you get the alcohol back. And of course, you're going to get water as your byproduct. तो हमें lithium aluminum hydride जो हम बनाते हैं, साथ ही साथ हम इसको डिस्टिल कर लेते हैं ताकि जो भी पानी बना है वो उड़ जाए और लहरदार हो जाए. Okay, so yeah, and that wraps up the last chapter of organic chemistry for us, and I hope आप लोगों को समझ आ गया होगा. Okay, if you have any questions, let me know.